Hello everyone. We are going to finish up our discussion of conic sections with the parabola, which actually brings us back to section 8.1 of our textbook. So just like the other conic sections, a section means a slice. And if you slice, as you can see in the picture, parallel to the slant height of a cone, the cross section that you will get is a parabola. The reason that I chose the parabola to go last is actually because it's mostly different than the other ones. In all the other ones, each of them had both an x squared and a y squared term. In the parabola, you're only going to have one or the other, either an x squared term or a y squared term. So let's talk about the definition of a parabola. The definition of a parabola is the set of all points in a plane, flat surface, that are equidistant from a line. That line is called the directrix, and a point, and that point is called the focus. And I'll illustrate that definition for you in just a minute here. There are two forms for the equation of a parabola. The general form, which looks kind of messy and it's hard to tell anything from, which is this one right here, and the standard form. And the standard form you might recognize. It looks a little bit different than the way you've seen it before. For example, you have not paid any attention to the p in there. Normally we ignore the value of p. Very often the value of p is plus or minus 1/4, in which case you would have a y term squared and you would have a x term, or an x term squared and a y term. You're probably most familiar with the vertical parabola, which either opens up or down. So what I'd like to do first is to go back to that definition of the set of all points equidistant from a given point and a given line. And the given point is the focus, and the given line is called the directrix. So let's take a look at this parabola that has a vertex at the origin over here and opens to the right. The focus is, if you pick any point on the parabola, which is shown in blue, the distance from that point to the focus is also equal to the distance from that point on the parabola to the shortest distance to the directrix. And you will see that over on the parabola to the right, which opens up. So while there's a lot of information on this page right here about both the horizontal and vertical parabolas, I don't want to get too bogged down in this. The standard form basically tells us the coordinates of the vertex are hk when written in that form, and that applies to both the horizontal and the vertical parabola. What we notice is if the y term is squared and the value of p is greater than 0, it is a horizontal parabola that opens to the right. If the x term is squared and p is greater than 0, then we have a vertical parabola that opens up. Likewise, if the y term is squared and p is less than 0, we have a parabola that opens to the left. And if the x term is squared in the equation and p is less than 0, then it opens down. We'll talk more about that in a few moments. We are going to skip over the next couple of pages of notes because that relates parabolas to parametric equations, and we're going to skip that in the interest of time. We're going to go right to this parabola summary page, and we're going to draw some really important information here. So the first thing we're going to do is start with this parabola on the left, and we're going to draw the focus in, and we will label that as the focus. And we are going to draw a line that is about the same distance from the vertex, and that is called the directrix. A little bit of vocabulary you'll have to deal with here. We're going to do the same thing with the parabola on the right. There's a focus inside, shall we say, the parabola, and then there's a directrix, the line. So Those two dotted lines are both the directrix. So any point on these parabolas is the same distance from the focus as it is from the directrix. So in the equations, you'll notice the value of P, and P tells us actually quite a bit about the parabola. The distance from the vertex to the focus has a value that's equal to the absolute value of P. The distance from the focus to the vertex also has a value that's equal to the absolute value of P. And that would apply to both the horizontal and vertical parabolas. Another piece of information that's really helpful, it's called the focal width. The width of the parabola at the focus, we'll label that focal width, is equal to 4 times the absolute value of P. And that again applies to both the horizontal and vertical parabolas. So basically, when you look at the equation of a parabola, either a vertical or a horizontal parabola, we can tell a lot by looking at the equation when it's in standard form. The first thing that we can tell is that the coordinates of the vertex, we'll call that V, are H, K. We can tell that the distance of the focus from the vertex, the focal length it's often called, is equal to the absolute value of P. The distance from the directrix to the vertex, also equal to the absolute value of P. And the width of the parabola at the focus is 4 times the absolute value of P, which will help us graph the parabola. And what I want you to remember is that if the x term is squared, the parabola opens up or down, y equals x squared, y equals the opposite of x squared. But I also want you to remember if p is less than 0, then it opens in the negative direction. So if the x term is squared and p is negative, then it opens in the negative y direction. And if p is greater than 0, it opens in the positive direction. So, for example, if the y term is squared and p is positive, then the parabola opens to the right, or in the positive x direction. So similar to all the other conic sections, I think the parabola is one of those things where you just have to work with it, do some problems, and kind of get a handle on everything. So what we're going to do is we're going to take these equations of these parabolas already in standard form, and we're going to write down everything we can about them and then graph them. So let's start with number 1. What I notice is this. I notice that x is squared and p is less than 0. So I know it opens down. The next thing I notice is that h and k are 0, so the vertex has coordinates 0, 0. I notice that 4 times p, the value out in front of the term that is not squared, is equal to -4, which tells me that p is equal to -1, and therefore I can go ahead and start graphing this thing. So I've got a vertex at 0, 0. I know that it opens down, and I know p is equal to -1. Well, that means that since we're just going to sketch a rough sketch right now of this thing opening down, I know that my directrix is the line above the focus in this case, and the line would have equation y equal +1. I know that the focus, squeeze that in there, I know the focus we'll call that f, has coordinates 0, -1. And now I want to graph this thing accurately, and I know that the width of the parabola at the focus 4 times the absolute value of p is equal to +4. So I start at the focus, I go 2 in each direction, left, right, and now I can accurately graph this parabola with that given equation. So let's try the one to the right of it, number 2. As you can see, the y term is squared. P is less than 0, so I know that this opens left or in the negative direction. I notice that h and k are both 0, so the vertex is 0, 0. And I also notice that 4 times p is equal to -6, so we got to do a little algebra here and solve that for p. So p is equal to -6/4, which simplifies to -3/2. So I know the distance from the focal point to the vertex is 3/2, or 1.5. The distance from the vertex to the directrix is 1.5. I also know that 4 times the absolute value of p is equal to 6, so I know the width of the parabola at the vertex is 6 units. So let's go ahead and graph that. So we've got a vertex here. I know that it opens to the left, so the directrix is going to be on the right, and that's going to be 1.5 units away, and that is a vertical line, and all lines have equations, and that one has equations at 3/2. I have a focus over here. The coordinates of that focus, we'll call that f, are -3/2, 0. And I know at the focus that the parabola is 6 units wide, so I go up 3, 1, 2, 3, and I go down 3, 1, 2, 3, and now I can accurately, I meant to draw that at 3 units away, I can accurately draw my parabola opening to the left. So we're going to end this video right here. This is just a first introduction to graphing parabolas. The next video will show how to graph parabolas that aren't centered at the origin, and we're also going to show you how to put parabolas that are written in general form into standard form by completing the square.